Hello, friends. Welcome. It's pretty late in the day, so I appreciate everybody being here. I'm Andrei. I'm a principal engineer at Atlassian, and we're going to spend about 30 minutes talking about GraphQL schema design. Super exciting subject. All right. What do I know about GraphQL schema design? So I've spent the last 4 years of my life working on Atlassian's new developer experience platform, Compass. And Compass we built from the ground up as a product using GraphQL. A couple of reasons why we did that. First of all, Compass is a product for developers. We wanted to make super duper sure that anything that you could do in the application, you could do through our APIs. The best way to do that seemed like it would be to just have our front end leverage the API and then to give everybody access to the API. That ended up working out okay. GraphQL sort of made sense for us because it was super early on in Compass's lifecycle, and we didn't really know where the project was going to go. So what we knew at the time was that we would have a bunch of pivots, and we wanted to decouple the front end from the back end. We wanted to make sure that anything we changed on the front end didn't require changes on the back end. So this gave us a lot of optionality and a bunch of freedom, and made that evolution sort of bit more natural. The other factor was that we wanted to build Compass as extensible as possible from day one. Atlassian has a serverless development platform called Forge, and Compass has support for that. So like anything that you see inside of Compass, you can probably extend or like add plugins for. That was is convenient, but it was also kind of scary for the development team because it meant that anything that we would change, like for the web application, we could definitely control the life cycle of those changes, and we can sort of deploy the front end and the back end at the same time if we need to break anything. With extensions, that life cycle was sort of different, and we weren't necessarily fully in control of customers actually upgrading their apps. So anything that we broke would probably stay broken unless somebody clicked the thing. So that made it slightly more risky for us. All right, I'm going to split this into three clumsily named sections. First of all, the basics, the things that we were looking at as like super straightforward going into it, and then we found out that were complexities there and bit us in the butt later on down the line. The hockey stick, essentially the things that we started finding out when we added a lot more contributors and a lot more traffic and a lot more users to the product, and we saw that we needed to change a bunch of things about our API. And the platform, essentially the things that we ended up building on top of. Atlassian runs GraphQL as a platform service, and there's a bunch of functionality that was really useful to us when developing the product. All right, in order to help illustrate some of the things in the schema and to save everybody from needing to learn about all of Atlassian's schema today in the context of this talk, I'm going to spend the next 30 minutes with schema examples that rely on pizzas. It's late, everybody's hungry, so I'm assuming that's hopefully going to be fine. Anyway, let's start. So I really dig GraphQL as a tool to explore APIs, and honestly, when putting together a query, a mutation, whatever it is, just being able to hit tab a bunch of times and land on something that is going to get me an actual response from the API and not just kick me to the curb is pretty great. And that was something that as we were putting together the API for Compass was sort of top of mind. We wanted to have this mantra that's like, if you can construct it, it should work, right? So as much as possible, guide our clients through the process of putting together requests. So let's take ordering a pizza, obviously top of mind. The way that we kind of structure this as an example, we only have like a certain set of pizzas that we have in our menu. We only have a certain set of sizes. Let's make both of those enums just to make it so that like we have a really good paved path for our customers, for our clients to go through. Now, enums are great, but there's a bunch of complexity when evolving your schema and evolving the values that are contained within enums. Obviously, again, when evolving your schema, most of the complexity comes from you have clients out in the wild who are not going to be on the latest version of your schema, who are probably rocking something that's like a day, a week, a month old. So you need to make sure that everything is copacetic and they still can get the data that they need. So let's go sort of, there's two prongs to this. Let's go through evolving enums on inputs and then evolving enums on types. So let's assume we're rocking an input and we're going to add everybody's favorite pizza, the Hawaiian pizza, arguably, well, not arguably, the best pizza in the universe at this point. What's going to happen for customers who are sort of still out in the wild and have an old version of the schema? Pretty much nothing. I mean, sadly for them, they're not going to be able to order the Hawaiian pizza, but other than that, they're going to be fine. They won't know what they're missing out on until they start upgrading their schema, but all the existing functionality is still going to work. All right, what if we ditch the margarita pizza because it is arguably inferior? At that point, for our clients out in the wild, essentially, everything else is still going to work. They'll be rocking the same restrictions. But every once in a while, somebody's going to try to order a margarita, and instead of getting kicked to the curb on the client, they're going to go out and instead of eating a pizza, they'll eat some latency because they now need to go to the server. The server's going to go like, whoops, margaritas aren't a thing, and then they'll get an error back. That error, they should have, the client should handle either way because hopefully you have more validation inside of your application than just is it a thing? So at that point, yeah, all of the evolution matrix for an enum as far as inputs are concerned, it seems fine, right? Whatever we're going to do with it, clients are going to be in an okay situation. All right, on types. Say we're rocking a similar schema, and we're going to still be talking about evolving our pizza recipes. All right, if we decide to once again ditch the margarita, there's some complexity here. So if you decide on a type you want to stop honoring a specific enum value, that assumes that you have done a bunch of hard work to expunge that value from all of your backing services. So that means if you say you're not going to have a margarita in your schema, then you can't have a margarita in your database. You can't have margarita, not the drink, the pizza. You can't have any of that anywhere in your systems. So say you've done that. The rest of this is pretty straightforward, right? As far as your clients are concerned, they're just going to have an if branch, a case branch, something somewhere that's going to be dead code because there will no longer be any values that can return that. At some point, they'll get the newer version of the schema and they'll be fine, but for the most part, they'll be okay. Now, if we're adding stuff to our enums, that's where things get sort of tricky. This can either fail loudly or silently. The loud part is if your clients are rocking a language that has first-class support for enums, then they're going to potentially get a deserialization error because now they're trying to go from this thing that is sort of serialized as a string, and they're trying to coerce it into an enum, and they're going to have a bad time because this enum value doesn't exist in their world. If your clients are rocking a language that doesn't have first-class support for enums, I don't really know, and I think that's even more problematic. You don't really know how your clients are going to handle it. You don't know what their failure scenarios are going to be, and that's not a great situation to be in. So the guidance that we have internally inside of Compass is, if at all possible, use enums for inputs, and then use an unbounded type for types. This sort of gives you it signals to your consumers that you reserve the freedom to pretty much change anything that you can return, and it gives them the guidance to be able to construct a payload that has high odds of being able to get serviced by your API. How do I word this? The succinct way to phrase this is bounded inputs and unbounded outputs. All right, moving on. I think we've talked about nullability a lot today, so I'm going to talk about it some more. This was one of the other things that ended up needing a bunch of adaptation as far as Compass was concerned. Nullability, again, I think the deceptive thing, it feels like a super basic notion. It feels like, cool, if something's always going to be there, it's non-nullable. I think that's right. If it's sometimes not going to be there, then it's nullable. Cool, you're on your way. The problem is like going from one to the other, depending on like, if you're on input or if you're on a type, is a breaking change. So that sort of limits what you can do with your APIs. So let's talk through our lovely pizza type here. And this would be pretty similar to one of the types that we would put together when we were first starting out on Compass. We'd have our backend engineers sort of look at the database schema and go like, cool, I have a non-null constraint on API, on size, on recipe. Surely all of these things are going to get returned from the same database in perpetuity, and they're going to get returned no matter what. And without fail, within a couple of weeks, our requirements would change, and we'd go like, well, you know what? Like now we want to do custom pizzas. Custom pizzas don't really have a recipe; they just have toppings. So now we have a breaking change, and we need to like explain that to some people writing extensions. We need to like make that work on our front end. Not great. The other thing that we can also have happen is we microservice super hard, and then, oh, sorry, as an apologies. The hydrated directive is an Atlassianism for grab this data from this other service and stick it into this type. So in this case, we would have ID and size coming from the pizza service, and then the recipe coming from the recipe service. Not to belabor the point, but like you kind of know where this is going. The recipe service isn't foolproof, and at times it can go wonky. And in that case, the whole thing is going to go away because we've told GraphQL, hey, a pizza is a thing that always has an ID, a size, and a recipe. The thing that we fed it doesn't have a recipe, therefore it is not a pizza. And then if we have embedded that pizza into a larger type, that thing blows up as well. And now you can't see your orders because the recipe service decided today's the day it chooses violence. So the overall guidance that we have now is that we tell our engineers to start with everything as nullable. And I think this is the overall guidance in like GraphQL best practice, but this kind of made it a bit more salient. And sort of go through each field on the type, and then it's a judgment call. If that field not being present warrants the whole type going away and exploding in a ball of fire, perfect, make it non-nullable. If not, you reserve the optionality to have it be nullable and like be able to make your schema evolve going forward. A lot of words, but to put it more succinctly, start with nullable first and then move on. All right, let's move on to the hockey stick. So as you get more and more people working on a product, more and more people consuming that product, more and more people contributing to an API, a bunch of things happen. First of all, your contributor and reviewer pool starts sort of forking off, and they're not going to be the same people. They're not going to have the same things in their brain. Not that they'll be less intelligent. They'll be just as intelligent, but like they're not going to have the same shared context. So the risk here, without having some nudging in place, some automation, is you will have an inconsistent schema. Now, an inconsistent schema, not at all a bad thing. The problem is you end up in a situation where your PR cycle time ends up being longer. The reason for that is, so engineers, the way that we've sort of seen this happen is they'll come in, try to make some change that they need to make for whatever area of the product they're working in, and they'll try to find some patterns that sort of look similar in your schema to what they are trying to achieve. Now, if there is one pattern in your schema, they go like, cool, I can grab this, I can change it, and then I can put up a PR and then be on my way. If there's 6 patterns, then that takes a bit longer. They need to figure out, like, well, of these 6, which one is the most prevalent? Which one of these things has been used most recently? And if you have an especially industrious engineer, they're going to go in, look at those 6 patterns, and go, well, these are all obviously trash. I will make a 7th one, and then try to get everybody to migrate their 6 patterns to mine, because it's better. That is a lot of conversation. That is a lot of time invested in what you kind of want to have be a more product-centric conversation rather than trying to like bike shit on what your schema should look like. So the guidance for us is the moment you kind of see this inflection point hit, sit your team down, figure out what you want your GraphQL schema to be like, figure out what your values are, put that on a Confluence page, obviously, and don't worry whether you need to like build tooling around it, and don't worry whether like you have the ability to lint for it. It's fine. Just put it on a Confluence page, put that on your PR template, and then go from there. You'll figure out when you need to build the tooling and what tooling you actually need. So in Compass, we ended up doing this, sort of going the same flow. We, for a while, tried to build our own linter because we had some pretty intricate rules that we wanted to see upheld. At one point, we were really thinking about doing GraphQL Clippy and having something just generate the type for you based on like, oh man, I want a blah, and then here's the fields, here's the connection, here's everything. GraphQL Clippy did not survive, but if you're looking to resurrect him, please let me know. The thing that ended up making everything sort of better was honestly having this sort of, what's the word I'm looking for? A critical mass of stuff in our schema, all guided by the same through line of, cool, this is kind of where we're going. And we ended up in this world where people would come in, look at the schema, see that like the one pattern was the one that's prevalent, copy it, paste it, be on your way. And that's, yeah, it's not glamorous, but it works. All right, so the takeaway from here is just set some ground rules. Whether you can enforce them or not, it makes sense to make sure that everybody is on the same page and you can link them to a thing and say like, cool, this is kind of what we're thinking. And then the tooling is going to happen as it does. All right, another thing here. So one of the great things about GraphQL is your clients can get just the data that they need, which is great. But there's some etiquette to it. You're sort of relying on people getting only the data that they need. And eventually you will get some clients who are more adventurous with their queries and they try to get all the data. And the moment that happens, you're probably going to reach for something like for implementing some sort of complexity cost limit on your queries. And there's sort of, the directive here is cost. It's probably going to be something else in your particular library. It might be weight, it might be whatever it is. The thinking there is pretty much the same. You have some numbers that are attached to your fields, and then when the query comes in, you sort of sum them all up. You figure out like, oh, is the number bigger or like higher or lower than whatever my limit is? And if it's higher, you go like, nope. And if it's lower, then I guess you just service the query. Turns out the really hard bit about this isn't necessarily implementing the behavior. It's figuring out what the hell the numbers are. I don't have a super good way about this. The thing that we sort of noticed was we kind of got to implementing this after we actually had like a bunch of other queries in the wild. So the numbers didn't really match up. Like we knew that we had some queries that were known safe because we'd optimized them. They were used a ton inside of other parts of the app. And then we had another bunch of queries that like some clients made that were very much not safe. And the two numbers didn't necessarily line up all the time. So the thing we were thinking through, and this is, I'll get to this later. The thing we were thinking through was like, well, I'll get out of the jail free card could be persisted queries, right? We just really find like this list of things that are sort of known safe, and then we just call them. You will notice that pizzas is not a valid 260-bit SHA. I apologize. I'll do better next time. But again, this is just one implementation. There's like multiple ways of like sort of calling persisted queries, but that is something that you could leverage if you find yourself in this situation where like your weights don't really match up with like what your usage is. All right, takeaway from all this is to, as much as possible, like as you hit this this trajectory, to keep control of your data. Otherwise, you will lose sleep. So one of those two is pretty cool. All right, so say you've done all that stuff, like you now have nulls all over your types. You are very much in control of your data. Your enums are on point, and you still are in the position where you need to break stuff. Like there's going to be a change. It's going to break some APIs. Some clients are not going to be happy. We run this situation a couple of times, and a fellow Atlassian sort of wrote this blog post about deprecating fields in GraphQL, and the larger takeaway was like, hey, you probably shouldn't deprecate anything. Just leave stuff around. It's fine. And sort of got me to thinking that they kind of had a valid point. Like a lot of my history with APIs comes from REST, and REST comes from this place of scarcity, where like if I have a resource, I only have a set number of HTTP verbs that I can throw at that resource. So if someone's done a put against the foo, I can't change the put against the foo. I need to work with the put against the foo and figure out like how I make that work with my new behavior such that people's old behavior still works. Now, GraphQL, by contrast, sort of comes from this place of abundance. There's an abundance of words that I can throw at a thing. So if I find myself in the position where order pizza is suddenly faced with a breaking change, there's nothing stopping me from like making an order pizza with cutlery and napkins. It's going to be wordy. Some people are going to have to type a bunch, but it is going to let me make the change that I need to change. Make the change that I need to make, and then it's going to allow like existing clients to still preserve their behavior, and everybody's happy, and everybody's can be on their way. So, takeaway for this: when in doubt, don't hesitate to duplicate. Man, I should have written that. That's like a lot catchier. Anyway, all right, moving on. Let's talk about the platform. Past the critical mass of services using GraphQL inside of our organization, it sort of makes sense to consolidate that spend. And however you want to do it, like you can either build it as a platform service where everybody consolidates on top of that and you have like hydration, whatever, or you can just have libraries. At the end of the day, you're still running a platform service. Now, at Atlassian, we had a pretty great experience running GraphQL as a platform service and having that schema all shared across the company. The caveat to that is we built our own GraphQL Gateway, and if you're interested in that, you can watch Andy's talk from yesterday that kind of goes into the details of like what that entailed and like how much engineering actually went into that. There's a bunch of heavy lifting that the platform team has done and a bunch of behavior that they've placed in the platform. And I'm going to be going through a bunch of the things that were super useful to us. So like I'm not going to be talking necessarily about like cross-service data hydration, subgraphs, supergraphs, like all of those things are kind of a known quantity, and like we've talked about them at length. These are some of the other things that as we built a product, we found pretty useful in reaching for whenever we had issues. All right, starting out, the first thing, lifecycle management has been pretty useful for us. So let me kind of talk about like what lifecycle management means. So schema introspection is equal parts amazing and terrifying when you're building a public API. The part that's amazing is that it powers things like graphical and allows people to discover functionality in your API without you needing to document it. The terrifying thing as you're building an API is that it powers things like graphical and allows people to discover functionality in your API without you needing to do much of anything. So for our engineers, that sort of meant like if somebody was trying to kick around some sort of field or some sort of top-level mutation that they were trying to figure out if that worked in the context of the whole application. It could be that they would put that in production, try to like feature flag it in, and then you would have one of our consumers find it and rely on it, and then not have any idea that that thing was about to get changed fundamentally because we were just kicking the tires on it. So that's not great. The thing that we kind of landed on was this directive. It's if you squint, it's similar to what we actually have in production. But it essentially tags a field as being in a specific lifecycle stage, so experimental, beta, or production. And then we sort of tag a program to it to help group like a bunch of APIs. And this kind of wires up into our documentation, and it's highlighted as like, hey, this is an experimental field, blah, blah, blah. The other part that's super interesting is having a directive when you actually, like a client-side directive as well, so that our clients opt into the dangerous thing. So it's basically a handshake where somebody goes like, yes, cool, I know I'm running with scissors, but I'm wearing Kevlar and a helmet, so I'll be okay, right? It's making sure that everybody is aligned on the expectations of maturity for these two, for the things that they're using. I think there's like an ongoing RFC for this. The directives are slightly different, but it's sort of similar in spirit. All right, rate limiting, kind of has a similar whiff to the thing that we were talking about earlier with maintaining control of your data. You can, like, there's a number of implementations of rate limiting in GraphQL. The thing that's been really convenient for us is not needing to implement our own and not having any of our downstreams need to implement their own, and having like one consolidated implementation for it. The upside as well is our gateway is authentication aware, so we can add these rate limits per user, per tenant, whatever we want. They're simple to use, and they're simple to sort of introspect when you kind of introspect whatever. See at a glance, let's call it that. Anyway, gotten a ton of mileage out of this, and I can definitely recommend adding this to your API, to your gateway behaviors as well. All right, I've gone through like a bunch of these. So the last one that I want to mention, OAuth scopes, like being able to enforce these in a schema has been pretty good. The main thing that's been useful about this has been whenever our developers are altering schemas, like the API, the OAuth scopes are sort of front and center, so it'll naturally come up as a thing in a PR where you're like, hey, which scopes is this going to abide by? Like, hey, this mutation, does this need write pizza? Does this need whatever else? Like, is the return of this particular thing going to abide by the scopes? You can naturally like do a bunch of this stuff within your application. The problem is like it's more easily overlooked there because now you have the other complexity of your actual business logic, and the schema is a bit more straightforward. Anyway, you'll notice like a lot of this functionality that we were talking to has been expressed through directives. There's a bunch of reasons for that. Again, like I recommend that you watch Andy's talk from yesterday. It's maintaining the compatibility of existing tooling, editors, and all that stuff. The other part of it is as a platform service that powers GraphQL stuff. Most of the people who are going to be using that service are going to also be GraphQL users. So the thing that they understand is going to be GraphQL, right? So whether your downstreams are written in Golang, TypeScript, JavaScript, Kotlin, Java, Haskell, whatever it is, a GraphQL schema is a GraphQL schema, and people who are using GraphQL are going to be able to make sense of it, and directives just make sense in terms of baking in that behavior. All right, so takeaway for this, push as much of your I guess common behavior down to the GraphQL Gateway level. The upside here is you're basically making your engineering spend more efficient. Like rather than having 5 different implementations of this thing across like 10 different languages, I guess that doesn't really make sense. Anyway, you're kind of consolidating it on some behavior that is going to be shared across everybody who is leveraging your constellation of services. All right, I think we're almost done. Let's do a brief recap of the stuff that we've gone through. So first of all, bounded inputs, unbounded outputs. Gives you the sort of flexibility to change your API going forward, and it also gives the guidance to your clients so that they're in a good position to make some determination about the payload that they're going to put in into your API and reason more about your domain model. Nullable first, I don't know, I think I'll have to say this like 10 billion more times, but that's actually worth saying 10 billion times. Set some ground rules as you kind of see so the API is sort of picking up steam. It helps you maintain some of that sanity around making sure that everybody's thinking about the API and how to structure it in the same vein. Control your data so that you can get some sleep, because sleep is good. When in doubt, duplicate. Again, GraphQL comes from a place of abundance, and use the abundant words in the English or whatever other language you're using for GraphQL schemas so that you can better express things in your model. And push common behavior to the platform. And that's it. Questions? Please. Sorry? Go back to the last slide. Which bit of the last slide, though? Okay. Please, sir, in the green.
I think spiritually, I always could be
About GraphQL Clippy?
Yeah, maybe not for now. Sounds very much like something that I want to
Yep.
Maybe you could say like why it wasn't a good idea.
I don't think it wasn't a good idea. Like at the time, the reason why it was interesting was, I think I was looking at the amount of linting rules that we were trying to cram through our linter, and I was going like, what actual decisions am I making here? Like other than the type is called foo, everything else seems to be a thing that the linter is just going to tell me no a bunch of times. So why not just have a generator? Why not just have something that goes like, bro, I want a foo that does blah, and then here's like the 20 lines of schema code to like make all that be true, right? Because like it sucks to have like the linter just go tell you like, no, 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 you're wrong here, here, and here. And it's like, just tell me the answer, man. In the blue?
What's your opinion of using the
Deprecated
deprecated directory?
directive is super useful. I think the thing that we have, the one rule that we have around that is to set a date on the deprecation. Like, hey, this is gonna die the, like whatever, 13th of October, and try to stick to it. Otherwise, it's like, it's really easy to go like, cool, this has been deprecated for 5 years. And it's like, sure, what does that mean? Please.
Can you re-explain the behavior when you deprecate the margarita enum? If the client side still has reference to margarita.
So is this for inputs or for types?
For input.
So for input, margarita, I guess that doesn't really matter. It's one of these. Okay.
So if the client side is still bound to margarita, but the server side decides to remove that.
Yep.
Right? So it's still going to push it.
It's going to push it to the server, right? And then the server is going to go like, nope. And that's going to be a validation failure. But again, the client should have some sort of graceful handling for validation failures, because like that's not just going to be like, you're not going to go like, cool, if it's in the enum, it's thumbs up, and like you're not going to check it.
The client solution is called because there is no more margarita done.
So right? Cool. Oh, please.
Are there any specific recommendations on the gateway you use for exporting API? How do you experiment with any other gateways other than Apollo?
We built our own, so like we didn't get anything off the shelf, because I think the moment that when we started building it, it was pretty early in the game, and there were no real off-the-shelf alternatives. Yeah. All right. Well, thank you, everyone. Please enjoy the rest of your conference. Stay safe, stay hydrated, and if you want to talk about this stuff some more, come grab me.